All right. This next trick, for my next trick, is actually one of my favorite little things you can do with volumes. We're going to do a kind of a pseudo simulation using velocity fields and volumes and all that stuff, but we're not going to run an actual pyrosim. Let me show you what I mean. This is going to be for the little fire effect that I mentioned. So go do an object merge. Let's get that statue. I want that statue. Where is that statue? Statue out. I'm gonna... So right now we're seeing the statue also here because I have, show other objects on, just so you know. But now we actually have the statue either way. And what I want to do here is say VDB from polygons. Let's get that. So we've got our sign distance field, or sign distance function. I'm never really sure which it is. We have that ready to go. Now I want to, again, make a volume, a fog volume out of this that's going to be advected through an arbitrary velocity field that we're going to make. So I need two things. One is I need the actual fog that's going to be advected through that. So let's reshape this SDF. You'll notice I'm doing it to the side here a little bit. In world space units, I want to basically grow this. Because the fire is going to exist on the surface, I need to have it, kind of be offset out a little bit. So I'm going to say let's offset it out by about 0.5. And then we'll say convert that VDB into a fog volume now. And to do that, we say convert do a VDB, which it already was. But now we're going to convert it to a fog from a sign distance function. So there you go. So that's what I meant. This is the volume now resting outside, and you can see it already. It's kind of going to blend into this other effect. But so it's resting outside by about 0.5. We needed it to be a sign distance function when we did this reshape in order to do this dilation operation, which means to expand it. If we wanted to reduce it, you could erode it instead. Erode goes the other direction. I'll hide other objects for a second so you can see if I erode it, it's eating away at it. Creepy, right? Another effect you could do, an erosion thing. Dilate, though, is what we want here. Where it goes the other way, gets bigger. But we don't want it to remain a sign distance function. We want it to be a fog so that we can actually do our actual foggy magic stuff. So in any case, I'm going to turn on the other stuff again. Now I want to do a similar operation on the right side here, but I want to create a velocity field that's even bigger than that so that this can be advected. It's going to read some velocity vectors and flow through it, much like the way a sim would do. So this one I want to be much bigger. I'm going to say make this one 2. This one we don't need to convert. Let's do a points from volume. This is kind of like as if we were making a source for a simulation in one of the other lessons. I'm going to make it a coarser point separation to 0.2. So it's 0.2 between each of these little points here. Turn on add scale attribute. You pretty much always want add scale attribute to be on with this, because later on when we do a volume rasterize, we need to know how much space each one of these points represents, and that's what the scale attribute is going to tell us. So we've got that, and we want to volume rasterize these points, or rather we want to, well, let's first, let's do a point velocity. So let's create some velocities on this. I'm going to say, I always turn initialization to keep incoming by default, because the actual default is it's going to try to make its own velocity based on any movement. Now there is no movement here, so there probably isn't actually a danger, but I find this trips me up a lot. So for the record, change it to keep incoming. But in any case, curl noise is what we want here. So turn on curl noise, and it's going to sample in space a curl noise function, which all that really needs to mean to you is a volume, a noise volume that will make up velocity vectors. So if I click on the view velocity thing here, you can see it's creating some new velocities for this. Kind of hard to visualize right now, but we can see that it's doing something at least. And more importantly, we have a v velocity attribute now, thanks to this. So I'm going to say, let us volume rasterize attributes. There you are. We've done this a lot. We wanted to do it to the v. It's showing us something, but this is really a velocity vector field, so this doesn't really mean anything to us. I would say, though, that we should take the point separation value here, copy that parameter, and paste relative references on the voxel size here. So there's a few ways to actually visualize a velocity field. I like the old school way, which is I take a volume slice of it. And this one already starts to make more sense because the colors represent, RGB means X, Y, and Z. But even better, volume trail, where we take that thing we just made as the input and have this go back to the actual place with the actual velocity field. And if we look at that, there you go. So this is a slice of what the velocity field looks like, in what it looks like over time as we scrub.